Hi there. The power bank that keeps on giving. Mysteries, that is. One of my viewers recently commented that he had trouble charging his iPhone with an ASDA blackweb power bank. I reviewed this power bank a while ago and did not spot anything then, and I have been using it occasionally, mostly to power Raspberry Pis and such, and it was working fine. Now I don't have an iPhone, so a Samsung A40 has to stand in. And indeed it isn't happy. Now I don't know if the problems the viewer had with his iPhone were similar, but that is indeed not good. Does it affect other phones? Let's try with my good old Wily Fox Swift, still running strong on Android 9 at the moment with monthly OS updates since I put it on Lineage OS. The power monitor shows 5 volts is available. Plugging the phone in shows a fairly normal charge current of somewhere between 0.5 and 0.7 amps for this phone, and the mode is shown as DCP 1.5A. Nothing wrong here. Let's try that again with the A40. Maybe the USB tester fixes it. No, the same warning pops up. The charge current is just 0.5 amps, which is the lowest by the USB power standards, and the charge mode is shown as unknown. I think I never used the A40 with this power bank, and since charging my old Wily Fox works, this problem could have been there for a while. The key to understand charging behavior in simpler or older chargers like this power bank is the configuration of the USB D+ and D- lines. You see, USB charging modes is a rather complex topic. The basics, at least, are quite well explained in this Maxim tutorial 5801. This is for the long superseded USB battery charging revision 1.2 standard, but in practice almost everything, phones, tablets and of course chargers, are still backwards compatible, so this is still useful information. This diagram explains the different types of USB ports a charger may present to the device. You notice that is all about the data lines D+ and D-. Those lines determine how much current you can draw from the +5 volt and ground lines of your charger or USB power bank in this case. Without getting too much into details, number 2 here is the dedicated charging port or DCP that can supply charge currents of 1.5 amps. Remember the DCP 1.5A shown on the USB tester earlier when charging the Wily Fox? Obviously that mode was then in use. This picture is also very interesting. It shows the various ways different chargers implemented the D+ and D- configuration. I came across this one here in the 1 amp configuration in my previous video on a strange USB power bank module from eBay. So many older chargers use voltage levels set by resistor dividers on D+ and D- to announce their capacity. But the simplest way is the dedicated charge, which just shorts the D+ and D- lines. The spec says the resistance between them should be less than 200 ohms, and a short definitely meets that. While my USB testers show the voltage of the D+ and D- lines, they don't allow any direct access. For that, I decided to modify my handy little adapter you have seen in a few other videos already. Notice the new pair of screws sticking out? Those are my crude but functional terminals to access the D+ and D-. The adapter is made of 2 USB breakout boards you can buy ready from eBay, mounted on a piece of wood. You can see that the ground and D+ and D- are wired straight through from the USB socket to a USB plug. The +5 volt is not wired through to allow insertion of a multimeter for current measurement. The 2 new screws simply tap the D+ and D- wires on either side. This thing is very cheap to make and invaluable if you troubleshoot anything with USB power delivery. Here it is in action for testing the Wily Fox. You can see that I need to insert a jumper wire into the red terminals to allow the 5 volts to pass through. The USB tester shows the same behavior as before, about 700 milliamps and DCP 1.5A mode. Since I now have access to D+ and D-, I can simply short them using the yellow alligator lead here. The current has not really changed, but the charge mode is now shown as Quick Charge 2.0. I don't believe there's actually a real change in the charge protocol here. It's just the USB tester trying to make sense of the D+ and D- lines. It seems that the Wily Fox Swift doesn't care about the D+ and D- in any case and simply draws whatever current it needs. They get away with it since that current is barely above the 500 milliamp limit set in the dawn of USB, and pretty much any decent USB port these days can deliver more. Let's see what the effect on the A40 is. Same configuration as for the Wily Fox with shortened D+ and D-. No error message and a decent current of 1.2 amps. Charge mode is again QC 2.0. There might be something wrong in the power bank with its D+ and D- circuit. Here it is, opened up. You can see the single 18650 and a small circuit board. If you are interested in more details of the power bank and its performance, you can click on the card to see my review and teardown of it. And here's that USB connector close up. There aren't any resistors in the area, just capacitors, which leads me to think the D+ and D- terminals in the middle should be shortened. I don't like the soldering job on the left one, which is D+. That leg seems to just touch the blob of solder underneath. Mind you, the other one, D- is not looking that much better. Yeah, the leg on the left one seems to have lifted off, or maybe it was never really connected in the first place. Let's see if that is true with a connectivity test. Well, the connector pins are certainly working, but that doesn't mean they are still connected to the PCB. But the standard probes of the multimeter are just too bulky and I need better magnification. Let's try it with a needle probe instead, using the video feed from my macro lens as a microscope. Yes, as suspected, there's no connectivity from the D+ connector leg to the solder blob underneath. But the leg itself is fine. Let's see the other one, D-. The D- leg is still connected to the PCB. So the problem here is simply a bad solder job. The soldering on the two D+ and D- legs looks quite different from the plus 5V and ground. In fact, it looks as if the middle legs of this connector slightly hover over the PCB and never touched its surface properly. The connector itself looks as if it was properly seated flush with the PCB. It could be a one-off, but if the D-legs of this connector brand are generally a bit short, this problem could well be in other power banks of this type. Well, let's fix it for the benefit of my other USB devices and phones. It is a rather tricky job, since I'm using the video feed and the camera tripod is kind of in the way. The D+ is now good. Let's do the D- just in case. I should have left this one alone. Oh well, not what I had in mind, but at least now they are definitely shorted. Well, it works. The A40 does not complain anymore and is happily charging at over 1.3 amps. So should anybody with this power bank break out their soldering irons? Not so fast. Instead of the A40, now it's the power bank's turn to complain by shutting down. For the reason, look at the front of the power bank. 5V 1 amp. but by shortening the D lines we have basically allowed 1.5 amps. While I did a load test back when I reviewed the power bank, that did not look at the long-term sustainable load current. To do that, I'm running the power bank connected to my electronic load, 1.3 amp first. After 5 minutes the power bank shuts down. Repeating the same test with 1.2 amp load current after resetting the power bank and then giving it time to cool down. At constant 1.2 amp overload it lasts for 14.5 minutes. So yes, it can sustain a bit of overload, but only for a limited time. This is a 1 amp power bank after all. You may have noticed during the load test that the QC 2.0 mode on the USB tester was flickering. Well, it turned out that mode detection isn't all that reliable. Here is the tester connected to the fixed power bank. It shows that the mode is unknown. If I plug my breakout box in, which acts just like a short piece of wire, hey presto, we now have QC 2.0 mode out of nothing. And to prove that just a piece of wire does that, let's replace the breakout box with a piece of wire. There you go, QC 2.0 mode again. Maybe it's the capacitance or noise that makes it do that. My other testers behave the same way. So what's the conclusion? I still can't charge my A40 on the ASDA blackweb power bank. Before the mod it was terribly slow, and now it overloads the power bank to the point that it shuts down after a minute. Personally, that's not a problem for me because I have other power banks that are far more capable, like this Xiaomi for example. But what if this is your go-to power bank and you are having problems charging a device from it? There are two cases to consider. If your phone normally charges faster on another charger or power bank, or displays an error message about the charge connection, like my A40, it could be the same problem I had, that the D+ and D- are disconnected in the power bank. But it could also be a DAF charge lead, for example one of those cheapies that simply have no D+ and D- wires. So the first thing to check is to make sure your charge lead isn't the problem. If that's fine, then you may want to try the fix I did, as long as your device doesn't draw more than 1 amp on a proper charger. And before shortening D+ and D-, please be more patient than I was and measure first if the pads on the PCB are really shortened. In hindsight, I wish I had spent more time measuring before soldering. The second problem is basically what you saw after I had fixed my power bank. The A40 charges for a minute and then trips the overload protection and doesn't get charged at all. The telltale clue is whether the power bank still powers on afterwards or needs to be first connected to be charged to reset the protection. We discussed this already. Basically, the reason is that the device draws more than 1 amp of charge current. Unfortunately, in that case, the only feasible solution I can see is to get another power bank that can handle more current. And on that cheery note, thanks for watching.